Hello, hi. Welcome to the basic electrical engineering lecture. So in the last class we have seen about the domestic wiring. Okay. There we saw how the wiring is connected from the mains to the houses, and inside the house how the wiring is taken to each meter board, switchboard, and we have looked into the earthing, importance of earthing, types of earthing, and the different protective devices what we generally use in our houses. Okay. So today we will start with another electrical machine, induction motor, and more specifically three-phase induction motor. Three-phase induction motor. So during the start of transformer chapter, I had discussed what are the different types of electrical machines we had. Okay, so out of those type of machines we already dealt two types. So the different types of machines are the one which will convert mechanical energy to electrical energy, that we call them as generators. The one that transfer electrical energy from one to other circuit, that we call transformers. Those two machines we already have gone through. The third type of machine is motor. Okay, so this motor, it takes electrical energy and gives out mechanical energy. It takes electrical energy and gives out mechanical energy. Okay, so we have come across these motors, and we come across these motors every day. Okay, we are using fans, we are using our water pump sets in our house, we are using mixers and grinders. Okay, we are using small toys. Okay, so wherever we observe the rotation, in all those cases we come across motors electrically. Okay, mechanically we will be coming across the engines, but electrically we come across the motors. So motors may size from few fractional watts to megawatts range. Okay, so the size may be few fractional watts. Okay, you can take a toys motor, okay, which will run at 1.5 volt battery also. The capacity of that motor is very less. It is not even 1 watt, less than that. Okay, 2 I can have megawatts range. Okay, where there will be a large irrigation application or water pumping applications, or in processing industry, in roller mills. Okay, generally I am talking about motors, not specifically the induction motor. Okay, so motors are in use for us wherever I need the mechanical energy as end output. If I want the system to be working electrically and I want the mechanical energy or mechanical work to be done at the end, we generally use motors. Okay, so motors are the largest energy converters in the world. Okay, motors and generators constitute the largest energy converters in the world. Generators convert mechanical energy to electrical energy, whereas motors convert electrical energy to mechanical energy. Okay, so simple, like I told, our fan, we switch on and we get the rotation. Okay, water pumping machine, okay, is a induction motor. Whatever the water motor we have in our house, that is a single phase induction motor. The fan what we use, ceiling fan, that is also a single phase induction motor. The table fan what we use, that is a universal motor, which works on both AC as well as DC. Okay, the motor that we use in our mixers is also a universal motor. It may work on both AC as well as DC. Okay, in hand drilling machine, universal motor. Okay, in lifts, conveyor belts, elevators, we use generally three-phase induction motors. Okay, so everywhere we are having the applications of motors. So wherever the mechanical work is done, we have the motors. Okay, even in electric vehicles, nowadays electric vehicles are booming in the market. Even in electric vehicles, we are having either DC motors or AC motors. Okay, if it is a large application, we have three-phase induction motor. If it is medium and small application, we have simple DC motors. Okay, especially brushless DC motors. Okay, what are those we will see in the next module, DC motor. Okay, so the thing is that motor has got application everywhere in our life. That was my intention to tell. Okay. So out of that, today we are studying induction motor. So there are different types of motors. Broad classification. Okay. Motors. There are various types of motors as per the application today. But if you broadly classify, motors are, okay, AC motors and DC motors. In these AC motors, we have two types, either synchronous motors and induction motors. Okay. We have servo motors, we have stepper motors, we have reluctance motors, brushless motors, so many of motors we have. Okay. And in the DC motors, we have, we'll stop there only in DC motors, because anyway we are studying the complete DC motor module itself. So in DC motors there are various types depending upon their connections. Okay, and in DC motors there can be brushless DC motors, okay. They have conventional DC motors that will be with brush. There can be DC servo motor, there can be AC servo motor. Okay, so many motors we have. So what we are interested now in this unit is to study the induction motors. Okay, so these induction motors will found the large application where the mechanical work has to be done. Out of all the motors, if you see, more than 50% of the applications are owned by induction motors. Okay, more than 50% of the applications are served by induction motors. Okay, so in this we have single phase induction motor and we have three phase induction motor. Okay, and for our study we have three phase induction motor. Single phase induction motor is not for the study, so we will not look into that. We have three phase induction motor for our syllabus, for our study. Okay, it means it operates on three phase supply, that's it. Single phase motors operate on single phase supply. Like I told, the water pump motor what we have in our house is a single phase induction motor. The ceiling fan is a single phase induction motor. Okay, whereas table fan is not induction motor. Table fan is universal motor. It comes under DC motor. Okay, DC series motor is called a universal motor. Okay. So with this classification of motors, we will actually go into the induction motor. So there may be a question why this motor is called an induction motor. Okay, why this motor is called an induction motor? Because it works on principle of mutual induction. Exactly based on the principle of transformer. Okay, transformer also works on the principle of mutual induction. Induction motor also works on the principle of mutual induction. Okay. Though why we use induction motor everywhere? When we have DC motor, when we have synchronous motor, why we use induction motor everywhere? Synchronous motor is used only when there is only one speed of operation. Synchronous motor operates only at one speed, that is synchronous speed. Okay. Whereas induction motor I can vary the speed, but variation of speed of induction motor will sacrifice the efficiency. The speed control of induction motor is obtained at a cost of efficiency. That is the biggest disadvantage. Okay. The advantages why we go for induction motor is that the construction of induction motor is simple. Okay, it is simple when compared to DC and synchronous motors. See, we have studied synchronous generators. So in synchronous generators, what we did, we kept armature winding in the stator, then we kept field winding in the rotor. We gave mechanical energy to the field, rotation, and we connected DC supply to the field winding. Now, if the same machine is supplied with the DC supply to the rotor and AC 3-phase supply to the stator, the rotor starts rotating in the form of motor. So any rotating machine can be converted to generator or motor depending upon how I supply. If I supply field winding and mechanical energy, it will give out electrical energy. If I supply field winding and electrical energy, it will give out mechanical energy. Okay, but the operation and efficiencies will be different for both the operations, but I can operate still. The synchronous motor can be operated, synchronous generator can be operated at synchronous motor. Okay. The advantage of the induction motor is that it is very simple in construction. Okay. The cost is much less when compared to DC and synchronous motors. Okay. The efficiency is much better when compared to DC and synchronous motor. The power factor is also good for this when it is operated at full load condition. Okay. The maintenance is very less, and biggest advantage is induction motor is self-starting. Okay. Biggest advantage is induction motor is a self-starting motor. It means that if I have to start the synchronous motor, I should give armature 3-phase supply and field DC supply. So 2 supplies I need. In case of DC motor, if I have to start, I should be supplying DC supply into the field and DC supply to the armature. Again, there we need 2 supplies. But whereas in induction motor, I have to simply supply 3-phase AC to the stator, motor starts rotating. What is the principle? We will look into that in the further topics. But it is a self-starting motor. I don't need additional supply to start it. Okay. Now, how do the motor work? That is very much important. Okay. Why the motor will rotate? See, every one of us has played with the magnets. Yes? I have 2 magnets here. Suppose I take bar magnet with north pole and south pole. I have another bar magnet with north pole and south pole. Now, when I keep these 2 magnets near to each other, now if I keep these 2 magnets near to each other, or what I will do is, I will keep this magnet fixed at one point. I will make this magnet, or I will move the magnet, second magnet near to the first magnet. Now what will happen? When this moves here, these 2 magnets, okay, will attract each other, because north pole is facing south pole. When the unlike poles meet, they attract. Now if I move in such a way that like poles meet, they repel. This every one of us know. Okay, that when I take the magnet in the same space, 2 magnets in the same space, okay, then when the like pole meet, they attract each other. When the unlike poles meet, they repel each other. This is a common kids play. But what do we understand from this is, now I will fix this magnet and I will simply keep this magnet near to first magnet. When this magnet comes sufficiently near to the first magnet, that is when the second magnet will come in the magnetic field of first magnet, it either gets attracted or gets repelled. Okay. So I have this one magnet. I don't have bar magnets, but I will show you with this round magnets. Okay. So this I will keep at a constant point. Okay. I won't move this hand, but I will take the second magnet near to this. Okay. See, you can see the repulsion. Please don't. Please trust me. I am not twisting this with my fingers. It is getting repelled. Okay. See, it is getting repelled. At one point it will get attracted. So when I keep at a far away point, there is no effect on this magnet. This is also magnet, this is both are magnets. Okay. These both are magnets. or this aluminum. So when the two magnets are far away, there is no effect. When one magnet comes near to the second magnet, if the poles are like, they attract. If the poles are unlike, they repel. See, there is a repulsion. Okay. So why this is happening and what exactly is happening? This is one magnet. It has got its magnetic field surrounding it. This is another magnet. This has got its magnetic field surrounding it. So when I take two magnets near to each other, both the magnets' magnetic fields, they now reside in the same space. Okay. Suppose this is the space of, if you mark the space of this magnet, now this is magnet. Okay. Now unless I take this near to this, it will come, it will attract. So let us mark some space here around this. Okay. Now, what is magnetic space? It is a magnetic field. Okay. This is the magnetic field of this first magnet. Now I will take second magnet near to this field. Now when I keep the second magnet near to, when I take second magnet near to this field, either the second magnet gets attracted or it gets repelled. It is getting repelled or it is getting attracted. Okay. What is happening here is, the magnetic field of this magnet and the magnetic field of this magnet, they both are interacting in the same space. Okay. Now when there is only one magnet, when I keep this magnet, surrounding this magnet there is only one magnetic field. Okay. Here I keep another magnet, surrounding this magnet there is only one magnetic field. Okay. Now when I keep these two magnets sufficiently near to each other, okay, or if I keep the first magnet into the magnetic field of second magnet and second magnet into the magnetic field of first magnet, what will happen? When I take this second magnet near to, I will show this here. If I take second magnet near to the first magnet, in this space, okay, in this space, the magnetic fields of both the magnets are interacting with each other. When multiple magnetic fields interact with each other in the same space, they gain some capacity to do the work. They gain some capacity to do the work. And what work they are doing? Either they are attracting or they are repelling. So work done is in the form of a force. A force is exerted. Okay? So when I take the first magnet, when I keep the first magnet at one point, and I take the second magnet near to this, okay, if the like poles are there, they will attract. Okay. So what is happening? There is a force exerted. There is a force produced on the second magnet. Okay. So it gets attracted. So when the unlike like poles meet, they repel. Then also there is force produced on the second magnet. So to attract something or to push something away, it needs force. So who is creating that force? If I keep two magnets individually, they won't create that force. The force is created on either both the magnets or either of the magnet when the two magnetic fields come in the same space. That is, when second magnet comes in the magnetic field of first or first comes in the magnetic field of second. So when multiple fluxes will come in the same space or will reside in the same space, they interact with each other. After the interaction, there will be a resultant flux created, and that resultant flux is now has got the capacity to do the work. Okay, so the resultant flux of these two magnets is either pulling or pushing the other magnet. The force is created by the resultant flux. Okay, so this is what happens with natural magnets. What happens with electromagnets? You replace these two magnets with electromagnet. Now do one thing simple. You have one coil. You keep one coil. supply a current to it, either AC or DC, whatever. I will not mention what type of supply, I will simply mention current. Now surrounding this, there is a magnetic field. Surrounding this, there is a magnetic field. Okay. So depending upon the lines of flux, I decide this is north pole and this is south pole. Now you take one more coil. You take one more coil here. Now pass some current through this also. It will create its own flux. Okay, let this be say flux 1, phi 1, let this be flux 2, phi 2. Now when these two coils are sufficiently far away from each other, no effect. It is carrying its flux, it is carrying its flux. They both are happily staying away. Now what happens when they come near to each other? Now what I will do? Second case, I will take this coil in the magnetic field of first coil. Current I. Now in this space, there are two fluxes simultaneously existing. The moment two fluxes exist, they interact with each other and get a resultant flux. Okay. So now, either of the two or both coils will experience a force. Now if I keep this first coil rigid or fixed, if I keep this coil fixed, and if I keep the second coil movable, then this coil will either get attracted towards the first coil or get repelled from the first coil. This is what happens even in electromagnets. So only there is one definition or one statement. Okay, what is that statement? Whenever a current carrying conductor is placed in a magnetic field, whenever a current carrying conductor is placed in magnetic field, okay, it carries current. Sorry, a current carrying conductor placed in a magnetic field, or current carrying conductor, or I can call current carrying coil, whatever. Current carrying conductor placed in a magnetic field, the conductor or coil experience a mechanical force. It will experience a mechanical force. Okay. So this is the fundamental principle of operation of motor. Okay. This is the fundamental principle of operation of motor. Every motor operates with this principle. Okay. So whenever a current carrying conductor is placed in a magnetic field, it will experience, the current conductor will experience a mechanical force. Why it experiences mechanical force? Just now I told. The two fluxes will interact in the same space, therefore either there has to be repulsion or there has to be attraction. In both the cases it is a mechanical force. Okay. So this principle we will make use, and then we will construct a motor. Okay. But I don't want the moving part of my motor to be linearly moving, because linear motion has got limitation over a distance. Now if I create an arrangement in the construction of the motor such that the mechanical force produced is obtained continuous at the same point, and that I can do by making the moving part of the system to be rotating. So the force is produced on the rotating part of the body about a fixed axis. That is how my motor starts rotating. Okay, so I will give current to one coil which will create one flux. I will give current to second coil which will create another flux, and I will make sure that these two coils are so near to each other that the current carried by both the coils will create flux that will fall in the same space, and they interact and force is produced. Okay, now to this second coil, if I provide the current externally, that is called conduction motor. Okay, if I have the first coil or the stationary coil, to the stationary coil if I provide one source current, and if I provide the rotating coil second source current, both the coils are carrying the current through conduction process because I am connecting two sources to them. That is called conduction motor. My DC motor and synchronous motors are conduction motors. Whereas now what I will do, I will simply short this. Okay, I will short this. The moment the first coil will carry the current, it will create the flux, and if the flux created is alternating, okay, the alternating flux will induce an EMF in the coil. Because the coil is shorted, the current is flown. Now the effect is current carrying second coil is placed in the magnetic field of first coil. The moment second coil starts carrying the current, it will create its own flux. Now how the current is generated in the second coil? It is through induction. Okay, so I am inducing the current in the second coil. That motor is called induction motor, and this is what I am doing in my induction motor. Okay, in the second coil I am inducing the current, okay, from the current flowing in the first coil. Is it transformer action? In transformer what I did, I supplied to primary and I placed a secondary near to the primary through core. Then the flux created by primary linked to the secondary. Because flux was alternating, the secondary winding got EMF induced in it. But it was through core, and there I did not want any rotating of the second coil or moving of the second coil. Now what I do, I will not put any core for the induction motor because I want rotation, I want moment. Okay, so therefore I will create an air gap between one coil and the second coil. Between one coil and the second coil. Therefore there will be an air gap between the stationary part and the rotating part. Okay, there will be air gap between stationary part and the rotating part, and that air gap will be so minimum, it will not be crossing more than 2 to 2.5 mm for the largest of the machines. The water pump what we see in our house is having air gap of less than 0.5 mm. You can imagine the gap between stator and rotor less than 0.5 millimeters. So small gap is given there. Okay, so this is how I will build the motor for my application. If I provide second coil supply, it becomes conduction motor, that is done in DC and synchronous motors. If I short the second coil and make the EMF induced, current induced, flux induced in the second coil, that is called induction motor. That is what is happening here. Okay, in induction motor. Okay, so now we got to know what is motor, how the motor is operating with its principle. The principle of operation of motor is this statement. The principle of operation of generator and transformer is whenever the change in flux is linked by the conductor, or whenever the conductor experiences the change in flux linking to it, an EMF is induced. That is principle of generator. What is principle of motor? Whenever a current carrying conductor is placed in a magnetic field, the conductor will experience a force. Why it experiences force? Because already I have a magnetic field. A current carrying conductor is having its own magnetic field. When that magnetic field come in contact with the first magnetic field, the two fields will interact and the force is exerted either in the form of repulsion or in the form of attraction. Okay? But in the motors, that force is in the form of rotation. Okay? Okay, that force in the form of rotation. But fundamentally, the force exerted between stator and rotor is again either a repulsive force or an attractive force. Okay, more of it is repulsive force, because if it is attractive force, motor will not rotate, rotor will not rotate. It will be more of repulsive force. Okay. So this is all about the fundamental understanding of an induction motor operation. Briefly, I can say principle also. Okay. Now we will move to the construction. For a moment, I will keep this diagram. We need this construction. So it is very much clear from this point that one part of the motor should be stationary, one part of the motor should be rotating. So definitely I will be having a stator and a rotor. Okay. So in the construction, main parts are stator, second is rotor. Okay. Stator is of only one type. Okay. It is stationary. Rotor is rotating, as the name suggests, and rotors are of two types. One is slip ring induction motor or slip ring rotor, and second is squirrel cage rotor. Slip ring rotor or cage rotor. Okay. Stator, first we will see stator, then we will see the rotor. Okay. Now one should be, the second coil should be moving. So I place second coil in the rotor. Simple. First coil should be stationary. I place first coil in the stator. Second coil should be rotor. Okay. So stator, using stator, the stator of three-phase induction motor is exactly like the stator of synchronous generator. There is no change. It is a hollow cylinder. It is a hollow cylinder. There in the generators we call the stator as armature. In induction motor we call the stator as stator. We don't call it as armature or anything. It is a stator and it is a rotor. It is a hollow cylindrical structure with the number of slots punched in the inner periphery. So on, these slots continue. Okay. And this contains, the slots contain the stator winding. So stator contains three-phase distributed AC winding. Please note, the difference is, in synchronous generator we had in a terminal box the DC supply also, plus and minus terminal for VDC, but in three-phase induction motor I give only three-phase supply to the stator. There are no any other connections there. Okay. Provided it is one type of rotor. Okay. Means another type of rotor we don't get any connections, but you just remember this. Okay. So it is exactly like the synchronous generator stator only. So this is yoke. This is stator core. This is base plate. This is rotor slot. Sorry, stator slot. Stator winding. This is lifting eye. This terminal box. Okay, this is terminal box. Fine. So stator yoke is made up of cast iron. This is made up of cast iron because it should be very hard and brittle. It should withstand all the mechanical impact on that. Okay. Stator core is made up of silicon steel laminations. This is made up of silicon steel laminations. Silicon steel is very good magnetic material. Laminations we use of that to reduce eddy current losses. This already we discussed. Base plate is again made up of cast iron. Okay. Whereas stator slots will form the stator core. Stator winding is made up of copper. Okay. It is three-phase distributed winding. Three-phase distributed winding wound for fixed poles. Okay. So here, unlike synchronous generator, we don't have physical poles in this construction. We don't have physical poles here. The poles will be rotating in nature. Why they will be rotating, we will get to know later. Okay. So we will be having the virtual rotating poles in the induction motor. Okay. So if you see the construction of the stator, it will look like this. Obviously there is no base plate and terminal box. I did not get time to prepare that all. Okay. So this is the stator of three-phase induction motor. Same stator will be like for synchronous generator also. So this is the diameter. You can see the outer part, whatever the white part you see, that is the yoke. The inner part, thermocol part, what you are seeing, that is the core, and in the inner part of the core there are slots punched. So this is a slot, this is teeth, slot, teeth. Okay, and it has got hollow cylindrical structure with certain length. It has got some length. In the last lecture of synchronous generator, I had shown you only the front section part. Now it is almost the motor stator only, of life size motor only this is. Okay. So this size of motor is almost equal to our water pump, 1 HP water pump motor. That doesn't mean it will rotate. It is just for understanding. So there are multiple slots punched in the inner periphery. Inside this, I will be getting the rotor. Okay. So I will be placing the rotor inside this. This is one type of rotor, and I will place rotor inside this exactly. And when I provide the stator supply, the rotor starts rotating. So from where I am getting mechanical energy for my application. Okay. So this is as of now only the stator construction. Okay. It is yoke, core, stator slot. Okay. Inside the stator slot there is stator winding. Unfortunately I could not prepare stator winding. Okay. Then base plate is not there. It is still under construction. My motor is still under construction. Okay. But at least you could understand what the structure of stator will be. Okay. So next is rotor part. Rotor of 3-phase induction motor. Rotor. Okay. So one type of rotor, there are two types I told. One is slip ring induction motor or slip ring rotor and squirrel cage rotor. If the rotor usually is slip ring rotor, I call that motor a slip ring induction motor. If the rotor usually is squirrel cage rotor, that is called squirrel cage induction motor. Okay. So first we'll see slip ring rotor. Okay. So slip ring rotor is having the solid cylindrical structure. Okay. And in this case, the slots are punched on the outer periphery. So these are slots and these are teeth. Okay. So the slots are punched on the outer periphery. So this was the rotor structure. This is teeth. This is teeth. This is teeth. Okay. And there will be a shaft. And upon this shaft, there will be slip rings provided. Okay, and slip rings with brush arrangement. And this is connected with external resistance. And these three, the other end of slip rings are connected with the winding, supply winding. I will redraw this in a proper way. Okay. So this is the rough construction of 3-phase induction rotor. Okay, slip ring rotor. If you see the elevation of rotor, it will be like this. So this is the slot, the shaft, and we have 3 slip rings made up of copper. And I have number of slots on the outer periphery. And I am drawing these slots purposely slant with respect to shaft. Okay, they will be slant. Okay. So in this, the windings carry 3-phase distributed winding. The slots carry 3-phase distributed winding. Okay, many number of conductors will be carried in each slot. It will form 3-phase distributed winding, and each slip ring is connected with one phase. 3 phases, 3 slip rings. So these are fixed. Okay, I am connecting each slip ring with one phase. The slip rings are made up of copper. Why I am using slip ring? Because I want to connect external resistance to the rotor. Already we have discussed in the synchronous generator how to connect a stationary supply or stationary circuit to a rotating circuit, that is through slip rings. So when the rotor rotates, slip rings will also rotate and they will be in contact with the external circuit through brushes. So this is the resistance. This is the resistance, star connected resistance we use generally. These are the carbon brushes. So these are carbon brushes. So this is shaft. These are rotor slots. This is rotor winding. Okay. This is a rotor core. This is external resistance. These are copper slip rings. And these are carbon brushes. We use carbon brushes. Why? Because it is soft material, so it won't create any damage to the slip rings. Okay, and if you see the complete wound structure of the rotor, it will look like this. Okay, it will look like this. So these are the slots. Obviously this rotor is of DC motor, not induction motor. Okay, just to give you an idea how the winding is provided, I have taken this rotor. Okay, this is of DC motor rotor. Okay, so there are number of slots. See, these are the slots. You can see the lines here. These each line indicates lamination. It is a laminated core, and one lamination is this. See, this is one lamination. Okay, you can see the thickness of one lamination. It is not even 1 mm. Okay, fine. So this is one lamination. When I use such number of laminations and punch together, I get a structure, rotor structure. So this is one lamination made up of silicon steel. Silicon steel is mild steel. It can bend. You can see very easily it can bend. So only I don't use silicon steel for the outer cover of the motor. It is made up of cast iron. Okay, cast iron will never bend. It is very hard and brittle. Okay, you see the shaft. Shaft is made up of cast iron. This shaft will never bend. Okay, it will break, but it will never bend. Okay, so this is the rotor structure and how the winding is provided. See, a lot of conductors you can see here. These are all thin copper wires. So wound in the form of winding. Okay, so this is the rotor structure. If you want to say exact rotor structure, I have a prototype. This is the slip ring rotor. Okay, you can see here. Shaft, unfortunately, I don't have. So this you can see. Slots, teeth, winding. 3 blue lines are 3 slip rings. 3 blue lines are 3 slip rings. This is also under construction only. So I could manage to show you whatever was possible. So see, the copper wire is kept in the form of winding here. Okay, so because of winding used in the rotor, this rotor is also known as phase wound rotor. Phase wound or wound rotor. This is known as phase wound or wound rotor. So this is rotor core, rotor slot, rotor winding, shaft, slip rings. Upon these slip rings I get 3 brushes. Upon this slip rings I get 3 brushes. So whenever the rotor rotates, my 3 brushes will be intact at their place. They simply slide over the rotor, and these 3 brushes are connected with external stationary resistances. And because I am using these slip rings, see, these rings are slipping on the brushes, hence it is called slip ring. Okay, so these 3 slip rings are connecting my external 3-phase resistance to the 3-phase winding which is rotating. So stationary body is connected to rotating body through slip rings. Because this structure is used, this is called slip ring induction motor. Okay, this is called slip ring induction motor. Okay, the advantage of slip ring induction motor is that it has got very good starting torque. Because starting torque always depends upon, in induction motor, the winding resistance in the rotor resistance. Therefore, because I am using a thick winding, you can see the winding of motor. So if you extend the length, the length will be very large, the resistance of winding will be very large. Therefore, my starting torque of this motor is very good. Okay, so this is one of the biggest advantage of slip ring induction motor. Okay, so the starting torque is good. I can connect external resistance. By connection of this external resistance, by varying this external resistance, I can control the speed of the rotor. That is biggest advantage. One more biggest advantage is that by controlling or by varying the external resistance, I can vary the speed of the motor. Okay. The motor is very smooth running. Okay, and the slip ring motors can be built for very large capacity. Because I am using winding, I can change the winding as of my requirement. Okay, so this is about slip ring induction motor. The shaft is made up of cast iron, rotor slots, everything is made up of silicon steel laminations. If you see laminations, you can observe here. Okay, these are the lines what you see here. The lines, each line is one lamination. Okay, so it is made up of laminations, silicon steel laminations. Okay, slip rings are made up of copper. Okay, slip rings are made up of copper. These 3 slip rings are made up of copper rings. Brushes are made up of carbon, because carbon is smooth material. But what is the disadvantage? The disadvantage is that it is costlier, because it has got winding, it has got slip ring, it has got brushes, it has to be punched with a number of slots. Okay, so it is a bit costlier. The maintenance is more, because there will be regular wear and tear of the brushes. So I have 3 brushes here which are continuously sliding over the rotating slip rings. Because of that, there will be wearing in the brushes. So once there is enough wearing of the brushes may lose contact over the slip ring and motor will stop the operation. Hence, there will be cyclic maintenance of the motor in the form of replacing the brushes or in the form of replacing the slip rings if they are too much wear out because of mechanical damage, in case if any. Okay, and all those things will make this motor costly. The size of the motor is larger for the same capacity when compared to squirrel cage, because this slip ring and brush arrangement will add additional space in the motor. This will add additional space in the motor. And because I am using winding, okay, see here, this wire is coming out of the slot. This wire is coming out of the slot. So there is still length of copper which is coming. See, this is the additional length of copper, this is additional length of copper. So I should make my motor more lengthier. The cover should be covering this additional length also. So therefore the size of the motor available will be more for the same cost, for the same capacity of the motor when compared to squirrel cage. And also the length will increase because of slip rings, because slip rings have to be placed after the winding. There should be sufficient gap between the slip rings and the winding. Therefore the overall length of the machine is large when compared to cage rotor. Okay, so this is all about slip ring induction motor. Okay, so in the next class we will discuss about the squirrel cage induction motor, that is cage rotor. Okay, or I will finish it now only because it takes hardly 5 minutes. Okay. cage rotor. So squirrel cage rotor. So in squirrel cage rotor, we will not be having this slip ring arrangement. This additional arrangement we don't have. Okay. Instead of using the winding in the rotors, in squirrel cage motor we use thick copper bars. We use thick copper bars, and these copper bars are not placed in the form of winding here. They are not placed in the form of turns. These copper bars are brazed at the end using end rings. Hope you know what is brazing. Okay? So these are end rings. End rings are also made up of copper. Okay? Then we will get a shaft. So rotor slots, we don't get rotor winding, instead we call rotor bars. Thick copper bar it will be, okay, thick copper conductor. Rotor slot, this is rotor core, and these are end rings. Okay, why it is called squirrel cage? Squirrel is an animal, okay. If you consider only the connection of these rotor bars with brazing of end rings, it will form a cage structure which in earlier days used to hold the squirrels in it. Okay? If you see the structure, so these are end rings, and if I brace, okay, these end rings will thick copper bars. Like this, it will form a cage-like structure. Okay. Then each bar is placed in one slot, and taking the end rings, I will be brazing it. So I will get a complete solid short circuit structure. Okay. So these are end rings, and these are copper bars. So this type of rotor construction is very solid, very strong mechanically. It is mechanically very much robust. So for all heavy load applications, I will be using squirrel cage induction motor or cage motor. It is also known as cage rotor. It is also known as cage rotor or squirrel cage. So when you see this structure, it will form a cage-like structure to hold the squirrels. Okay, I have a small prototype for that. This. These two are the end rings, and this is a copper bar. Okay, so you can consider this as one thick copper bar. Now see the cross section of wire and the cross section of bar. So this is wire. So this is a wire. Okay, or winding for what we use. This is the conductor that I use in my squirrel cage motor or rotor. So this very thick copper bars. Obviously this is not copper. This is a wood. This is a prototype. Okay. So when I open the core of the motor, if I see the structure, the cage rotor will be of this structure. Is it forming a cage structure? If I close both the ends, it will form a cage, right? So this type of cage in earlier days used to hold the squirrels, hence it is called squirrel cage rotor. That's it. Okay. Now these are the end rings. You can see at the end rings the copper bars are braced. I used Fevicol here, but actually it will be braced. Okay. So these are the copper bars are braced here. Now is it an entire short circuit rotor? Electrically this is completely short circuited system. In the slip ring rotor also, I used the external resistances and I shorted all three resistances on the other end. So the rotor of induction motor should be always electrically short circuited. If not, it won't operate. Why it won't operate, we'll see in the principle. Okay. So this will form the squirrel cage rotor. Now every bar is placed in each slot and these copper end rings are connected to the bars and they are braced at each conductor. So this will form very solid structure. Mechanically this structure is very much robust. So generally what we do, we don't use slots. Okay. Now you simply remove the winding, place the bars here. You just place the bars, you use end rings, you remove this slip ring. Okay. That will become squirrel cage rotor. But generally what we do, we don't use the slots here, we punch the hole and I place the conductor or insert the conductor and I brace the conductors on both the ends using end rings. This will form the squirrel cage structure. So this is slip ring induction motor rotor, this is squirrel cage induction rotor. This is only the structure of cage. Rotor will not be this much hollow, please don't imagine like that. Each conductor is placed in one slot like this. Okay. So each conductor is placed or bar is placed in one slot and at the end, taking two copper end rings, they are connected and braced. Each conductor is braced at both the ends. And if you see the structure, the conductors are not parallel to the shaft, they are slant, they are skewed. Why they are skewed is, I told, when the two fluxes meet in the air gap, either there can be attractive force or repulsive force. If there are attractive forces generated, then the rotor will get attracted towards the stator and it will never move. It will be locked. That is called magnetic locking. So to avoid the attraction of this conductor throughout, you can see here. Okay. So throughout the length of the motor, the conductor will be having attractive force with the stator winding. Then each rotor conductor is getting attracted to each rotor slot. Therefore, the rotor will refuse to move. It won't move, it won't rotate. It will magnetically get locked. That is called magnetic locking or cogging. To avoid this problem, I simply make the conductors skewed. The slots I make skewed and automatically when I place the bar will get skewed and there will not be attractive forces throughout the length and it will not cause the magnetic locking. So to overcome magnetic locking, whether it is slip ring rotor or a cage rotor, the slots are skewed. Therefore, the magnetic locking is avoided. Because of this very strong mechanical construction, this is mechanically very much robust and used for large load application. This is one of the biggest advantage. The second advantage is it is very simple in construction. Take the core, punch the slots, put the bars, brace with end rings. Construction is over. Okay. Another advantage is maintenance is zero. I need not to maintain anything here. Simply I have to place it. Okay. And efficiency and power factor is better, okay, for this cage rotor. And there can't be any fire hazard like the slip ring. In slip ring, the carbon brushes are sliding over the slip rings. Therefore, there may be a spark between the brush and the slip ring and it may cause fire hazard. There is nothing of that sort. So therefore, it is less hazardous. Okay. So life of the rotor is very good. Disadvantage, it has got low starting torque. Because of thick copper bars, the resistance of copper bar is much less than the resistance of winding. Per slot, only one copper bar. So the resistance of resistance per slot is only resistance of this bar. But whereas in case of slip ring motor, so many conductors I have. R equal to rho L by A. Area is less, length is more. Therefore, resistance is more for this winding. Area is more, length is only this much. Therefore, resistance is very less. Because resistance is less, starting torque is less. Okay, that is another disadvantage. Okay. That is the major disadvantage. The starting current drawn is large. Because resistance is less, current drawn is more. So starting current drawn will be around 5 to 10 times or 6 to 10 times than the rated current. If the motor rating is 10 amps, at the start without using the starter, it may take around 80 to 90 or 100 amperes. So that is hazardous. So this is all about construction of my induction motors, stator and two rotors. In the next class, we will look into the rotating magnetic field and the principle of operation of induction motor. Okay. Thank you for joining the class.